Hey, and welcome back to another Learning Java 2D Game Programming video. So in our last video, we implemented the endless game state. So it is a game mode where you start with this sort of small map, and when you clear it, you move on to a bigger map with more NPCs. So unfortunately, the audio was not recorded for this video, so I will do my best to narrate the video that I captured here. So this is all working quite well. We can play, will probably eventually fail, so we only have 2 minutes. But what I found when we were using this is that now we can get to a point where our maps are so big and we get so many NPCs that our performance is suffering. So we need to do some optimizations, and one of those optimizations has to do with the Pathfinder. So currently, our Pathfinder is using a static method. And what that means is that we are instantiating everything that we need to find a path inside of this method. So we are instantiating a bunch of objects, and then we are finding our path. And then the garbage collector helps us, getting rid of those resources and whatever. And this is done for every time an NPC is asking for a path. So we are gonna help it out a little bit by not forcing it to instantiate these objects every time, which means we are gonna keep an instance of the Pathfinder, which in itself is gonna keep an instance of the node map. And we're gonna keep this instance of the Pathfinder inside of the game map. But before I do that, I'm just gonna show you what I mean. So here in the handle input method of the game state, just gonna make that protected so that we can override it inside of the endless game state. So let's just override the handle input method. Remember to call super. So I'm just gonna check if input is pressed key event vk n. So if it is, let's just call win. So now we just have this sort of little cheat button that'll let us win any sort of map. So I'm just going to show you what performance hit this pathfinding thing that we are using has. So here we are, 100 NPCs, and you could see I was walking and then it froze. So the game froze, but then it thaws after a while. So what is happening is that just like we just talked about, it is creating a lot of objects, destroying objects. It's taking a lot of resources. And currently our NPCs, they all stand still for 3 seconds and then they all start walking at the same time. So all the NPCs are requesting a path at the same time. And that's what happened there. And it was a bit too much for our system to handle. And that's why it sort of froze while it did that. So first of all, what we could do, of course, is not let all of our NPCs stand for 3 seconds and then start walking at the exact same time. So that's absolutely something that we're probably going to fix. But before that, let's just fix this issue with the Pathfinder so that at least that isn't an issue for us. So I'm just going to pop over to the Pathfinder class and I'm going to remove static. So this will be inside of the game map class. And we are going to keep these as instances inside of this class. So the priority queue and the closed set of nodes. We are also going to have another set that I'm going to call unavailable. and then the node map. All right, so let's make a constructor. And don't take any of those in. We are going to take in a game map, which will be the game map that we use to initialize our nodes, well, this Pathfinder. So first, let's just create these instances. So open is a new priority queue, close is a new hash set, unavailable is a new hash set, and node map is whatever's down here. All right. And so we can remove those things, but we need to clear these now. Since we are reusing them, we need to make sure that they are in an initialized state. So we are clearing the open, we're clearing the closed, and then we're adding all of the unavailable nodes to the closed set. So now let's copy this double for loop and paste it in the constructor. So we're going to initialize our node map inside of the constructor, and we don't know the heuristic because the heuristic needs the start and target node. And currently we don't know that. So we're just going to pass in 0. And instead of adding the unavailable nodes directly to closed, we're going to add them to unavailable instead. And as you know, down here, we are immediately adding the unavailable nodes to the closed set when we are finding a path. All right, so now we don't need to create a new node there. This we don't do. We don't need that. So we are just setting the heuristic directly on the node map XY. Heuristic is equal to what we had before. And then since we are reusing these nodes, we need to also clear them as well. So that would be the total cost will be 0. And also the parent needs to be null. All right, I think that's it for this class, at least at the moment. So let's find the game map class, which will keep the instance of our Pathfinder. So let's just declare it at the top and initialize it inside of this constructor. And you pass in this as the game map that will be used for initialization. All right, and at the bottom, I'm just gonna expose a method that sort of wraps the FindPath method. So it's gonna return a list of position. I'm gonna call it FindPath, and you send in a position start, a position target, and that's it. So we return the Pathfinder FindPath from start to target, and using this as the game map reference. All right, so I'm just gonna press play to see where stuff broke. So inside the map generator and inside the Wander AI state. So let's go to the map generator. And here you can see in generate roads, we are using the Pathfinder, but we're only using it here. So let's instantiate it inside of this method. We only need a game map, and we have one. All right, now we can use this instance instead to find the path. So great, let's go to the Wander AI state. And now what we do here is, of course, we use the state dot get game map dot find path. And then we don't need to pass in the state there. Or the game map, sorry. All right, so that's probably done, but we have one more issue. And that is if we go up here, currently we create the Pathfinder when we create the game map. And here, that is before we've generated the unwalkable water tiles or we've added any of the scenery objects. So, I mean, the Pathfinder basically keeps a cache of what the unavailable tiles looked like at the time of initialization. So we need to sort of update that cache, if you will, to reflect what the game map looks like currently. So in order to do that, let's just create game map dot refresh. So I was thinking a little bit about the naming here. What does the refresh really say? So maybe refresh Pathfinder. I think that's what we are going for currently, at least. So this will sort of refresh the cache so that it reflects the state of the game map currently. And what this will do really is just make a new Pathfinder. So with the game map's state as it is currently. All right, so let's try this out. So I'm just winning a couple of times and let's just see if it still works. So it still looks like it works. And they're avoiding the objects and they're walking on the dirt. So, okay, let's continue to when we get to the 100 NPCs where we could see it freeze the last time. So now you can see walking there and it didn't freeze. It might have stuttered just a little bit, but it was hardly noticeable if you compare to the complete, screen freeze that we had before. So this is looking quite well. So at least we got rid of that problem and we bought ourselves a few more levels that we can go up before it gets very performance heavy. And as you can see, whenever we move on to the next level, it still goes down a little bit, the frames per second. And that's of course because of the map generation and all of that. It takes resources. So when we are generating the map, we are taking a lot of resources. But then when we're playing, it's going quite well. But here is another optimization that we're gonna do. Inside of the state, when we do get colliding game objects, we are sending in a game object, and then we are looping over all of the game objects in the state and checking if we collide with them. And this means that even if we have a very large map, like every game object will check every other game object. So the player might check with all of the trees, which might be very many. So since the collides with, which checks these rectangles if they collide, if they overlap, it is more performance heavy than just checking the distance between the positions. So we are first filtering by the distance of the positions. So this is a little cheaper than that. So this means that we are only gonna check the collides with on objects that are closer than 2 tiles from us. So this will also improve performance a little bit, but I don't think it will be noticeable right now. Not the way that the other performance optimization was. But now we've done that, so I'm just trying out some different. So there, as you can see here, at least we still have around 200 frames per second, and now we are at 140 NPCs. So we bought ourselves a few more levels. We could probably keep playing a few more levels like this. But as you can see here, The map is very big and we can hardly see any NPCs. So, from a gameplay perspective, this is going to be very hard. So, that's actually something that I'd like to change. So, this isn't really a performance optimization as much as, I don't know, gameplay preference, gameplay, I don't know. So, the first thing that I want to change actually is not to have this completely square map when we begin with. So, our window is a lot wider. So let's make our map wider as well. So to do that, we are going to find the menu. And the UI and the UI main menu. So here we are creating the new endless game state. So let's just set the width to 16. So that should have fixed that. But also let's not make it as big for every new level. So go to the UI endless win menu and I'm going to just add 2 instead of 5 for both the width and the height. So that way the maps aren't going to grow as much and we're going to concentrate the NPCs more. And I'm already liking that it is a wider map. It looks better. There you can see it didn't grow that much. But now we are concentrating our NPCs more. So that's good. All right, in the next video, I think we're going to start looking at pseudo randomness. So that means that we can initialize a random object with a seed, and that means it's going to be same random. So if we've given it the same seed, it should generate the same map for us every time. And that way, we could share seeds with each other and therefore play on the same generated maps and sort of, I guess, compete with each other if we would like and compare scores. So that's going to be fun. And hopefully, next time, my audio will work. So thank you so much for watching, and I will see you soon. Hej då!